Well, hello everybody. Let's see. Back to the Grundig. It's a 2140. Got the lower. Oops. I guess that's the FM. So I push that button and the FM pointer goes. I didn't cut the excess off yet. I want to make sure that everything works. So something I found on this, which maybe somebody else has run into, and I found a solution for them. And from what I've been watching, there's a fellow electronics, new and old, or old and new. I'd have to double check his website. Really, really informative. He does a lot of work on the older European and German radios. But I was watching a lot of his, and just it seems like every one of these is different. And I went to do it yesterday to record it, but I didn't have the SIM card, and it's probably better off because all you would have got probably was between all the swearing and my head in the shot. So this, as you saw, has two different pointers. Move that out of your way, maybe it'll light it up a little bit. It has two different pointers, one for AM and medium wave, and then one for FM. This is the one I have to make because I don't have it. But I don't know, I took some dimensions, maybe I'm right, maybe I'm wrong. Anyhow, so what happens, there's actually two different dials, and as you saw in the front, and I can show you again, there's two different tuning capacitors. There's one for FM and there's one for the AM medium wave. So in order to make that happen, if you look in here, and I'm going to zoom in, there's basically an idler pulley with a clutch on it. Not really a clutch. Let's see if I'm zoomed into the right area. I'm going to try and zoom in even a little bit better. There we go, it's focusing. It's kind of hard to see it. I'll see if I get you a better view, maybe if I turn this a little bit more. Yeah, there you go. So you can see there's a pulley here that the string's in. Let me find something small that I can point with my gigantic finger. The string for the FM goes through this one, and there's a pulley just like it on the other side over in here, but there's no string on it yet because that'll be for the other bands. And this has basically these two wheels. There's this wheel here and this wheel here. They freewheel on here. But see this little guy in the middle, the silver thing, and I'm trying to show, yeah, there, if you can see this little silver thing here, it moves back and forth by this little pawl, P-A-W-L, pawl, or paw, however you want to say it. This moves back and forth, and when it does, this metal piece right here is attached to the shaft that goes through. This metal piece, it doesn't spin. If it spins, the shaft's spinning. But what happens, it has like kind of like little brakes, and if you push it to the FM or the AM side, or rather the FM side, it'll push this away and hold on to it, and then this spring right here will allow spring tension to push this against this, and there's a little. Well, that was the problem. There was a little almost nothing in between. What did I do with them? Somewhere I had these little holders, but they looked like little pieces of kind of cork rubber. So what I did was I actually found, fortunately with this one, the way it worked, I was able to leave everything intact. I took it apart, but I mean I was able to save everything, and I got some rubber. Let me see if I can lift a little bit higher so you can see better. But I put a rubber washer in between them. And there's little extrusions on both this pulley and on this center gear, or not gear, I guess for lack of better words, it's a gear. But and what happens when the spring tension here pushes against it, those little extrusions bite into the rubber, and they allow it to spin. So you can see how it's. If I come at it from this side, you'll see how the shaft's spinning. But if I push this, so you'll watch this pawl is going to move it. I'm going to push it to one of the other bands. Let me get my arm out of the way here so you can see it happen. So now, when I spin it, that's the AM/FM side. See, the gears wanted to turn, but it's no longer pushing against the rubber and pushing against this. It's pushing against this pulley on this side, and you can see it, this one's moving now. So that's how that works. Anyhow, like I said, it was all it wasn't working, and what I did was I was able to get it. It comes apart pretty easy. There's an E-clip in here, and you just slide. You kind of get in there, be imaginative, and slide the spring away from the wall, and then you can get under the screwdriver and pop the E-clip off. And when you do this, it pulls right straight through. That being said, when I was doing this, one of the things I did find was this shaft. These gears should just freewheel on this shaft. They shouldn't. No, not that side. They shouldn't. They should just be able to turn freely. It should be this little guy here and the rubber on each side of it that controls the friction for it. This shaft was kind of galled. I couldn't even hardly get it out of the pulleys. I pulled it out and I cleaned it all up with some carburetor cleaner and shined it up with a little bit of steel wool, and the same thing with the inside of the pulleys, and they ride nice and smooth. I put a real thin coating of oil on it, and now they ride nice and smooth, so that the gear that's not, well, you can't see it with my hand, the gear that's not chosen doesn't want to turn at all. So I went and I got that part all taken care of. But anyhow, that's kind of what it looks like. So if you're working on one of these and you have one, you can go to your that you want to fix. You can go to your local hardware store like Lowe's, Home Depot, and buy those washers. They're called rubber fender washers, and that's because they're the big gigantic washers. The inside was, I think, 1/4 inch, and I started with 1 inch on the outside. They were actually too big. I think I ended up with about 7/8 by the time I was done, because I had to keep trimming it so that little paw that moves back and forth wasn't rubbing against it, because that would defeat the purpose of everything. And here's, like I said, here's the two different tuners. This one has the string on it already. That's the FM. Here's the AM midway. So I'll take a look at that, and we'll be able to hopefully make that up. The other pulley, I can get that done. Update with over here. I calculated that, and I can, if it works out to be correct, just by what the schematic says, I calculated that I'll need approximately a 320 ohm resistor, probably a little bit more, a little bit less. See, it's not going to be exact, but something along those lines to put in series with this, and I'm sorry, to put in between the positive lead and this capacitor. What else? Oh, the fuses. Remember, I told you I was having issues getting the fuses that fit right for back there. And again, if you're working on one of these, I'll show you what I ordered. That's a 600 milliamp fuse, or 0.6 amps. And here is the exact fuse I got. Got them from eBay. A Belmore fuse. Let's see if it's got a part number on it. Gee willikers, it does, but I can't see it. But let me see what the fuse itself actually says. Oops. Yeah, I guess you heard that. That just hit the bench. So let me pause this and I can see if I can look underneath it. How creative. That doesn't say anything either, except 0.6 of an amp. But so they're the 5 by 20 millimeter, I believe, is what the measurement of them was. Of course, you won't find those at your local hardware store, probably. What else? Oh, I also ordered a new, what's it? FG6 is, I think, the US number, but it's yeah, this schematic works great. I think it's an EM84. I'll have to double check. But this was the one that was real dim, and I didn't really get to check yet to make sure that the driving voltage works for it. Basically, it should be a negative voltage to the grid side, and and it should get more negative. I believe, yeah, it gets more negative as your signal strength gets stronger. So we'll double check all that. And it looks like everything else is moving along, and I will keep you posted as we get the next things done on it. Just wanted to show you that in case anybody was wondering how they were going to handle that clutch assembly or whatever you want to call that. But like I said, from what I've seen, no two look to be alike. It's not like they found a method and said, hey, this really works, we're going to stick with it. So I want to also start the wrong way. I also want to start to clean it up a little bit more. You know, I did clean it up. Most of this is not just dirt anymore. It's wear. You know, I mean, it's rusted. This was they had. I don't know if this was part of a reflector that helped to keep the light bulb light shining back in, but there's not much to it now. It's all rusted. So I'll keep you posted as things come in, and hopefully we'll be able to put it back together soon. By the way, that's my chair that makes all this weird noise. Yeah, I know. I'm trying to. Yeah. Okay. Okay, I'm checking the voltage on the grid pin here. Even though, like, that's really dim. You can't really, I don't even know if you can see how dim that is, the bulb. But even with that being said, as my signal increases and decreases, that signal doesn't, that voltage will show you up there. It's 654, just kind of fixed at that, no matter what happens to the signal. So I'm curious to see if that's a problem with the tube. Okay, so I pulled the wire off the tube, and I have just the wire coming back from the tube, the IF circuit. And let's see, as you can see, it's a now it's a minus voltage, but it's a minus decimal point. I don't know if that's. Let me see when I tune something in. As I tune something in, it definitely gets more negative. I'm just using my hand as an antenna, so I don't know if that's an acceptable. I'll have to check what the voltage range is. For some reason I thought it was whole numbers. I'll try with a AM or medium wave signal and see what happens. Now it's getting way higher number negative, so it's getting more negative. So I think whatever it was in the tube was holding it steady at that, whatever that voltage was, and we'll find out for sure when I get the new tube, and we'll go from there. But I just wanted to show you that because I was kind of curious about that too, what kind of voltage it took to actually drive that to close, and I guess I really could look it up because it's an easy enough tube to find. Alright, so today we're working on the bending the AM and mid-wave or mid-band needle for this, and if you can remember, yeah, I have it screwed on there. Anyhow, I got a piece of 16th inch steel, and I'm going to attempt to bend it. If you remember, I had this diagram here, and this is what I'm after. So I'm going to attempt to bend it to meet that specification as best I can. I kind of extrapolated with how big it would be as compared to what the drawing size of this one and the actual size is, and decided that that was the ratio, and I'm going to build on this one. So I'll give it a couple bends and try and get that together, and then I'll string it, and if everything works right, I'm going to get a little bit of that Tester's model paint and red to paint the tip here, and then we'll be good with that. The tube and the resistor for the power supply did not come in yet. It was supposed to be here yesterday and didn't make it, so I thought maybe today, and Still says it's in transit, so I don't know if it's the COVID-19 has slowed down the mail a little bit, but no big deal. Whatever. Whenever it gets here, it gets here. It gives me time to work on this. So we'll be right back when I get this bent up. And then through the marvel of YouTube and the camera, I don't know if you can see this, I've got a couple of bends on this already. That would be it. Gonna do a few more bends and keep you posted. Okie dokie, so here, and I'll zoom into that, is the finished product. At least what I've extrapolated to be the finished product. And it looks like it would work roughly if you put that to about the halfway point through there. I think it's going to have to be bent a little bit more. To me it looks like a perfect 90, but we'll find out once we get the string attached to it, how much it's going to fall. And here's the string, so I'm going to go ahead and string it, and then if it fits and everything looks right, then the next thing I'll do is I'll sand this down a little bit, the edge, and we'll put some red paint on it, and then we might be done. So I got to get another spring and this, and we'll be back. Oh, I did forget to mention that I do have a helper in the shop today, and it is Chris 2.0. He's hiding from the camera. It's not the real Chris, it's the imposter. It's Steve, the imposter, the Chris imposter, so the impersonator. He's still trying to hide. I can't point it at you, I'm not magic. So anyhow, that's our visitor in the shop today. Say hi to the boys and girls, Steve. Hello. That sounded real official. Okay, so I got the new dial made, and I still have to heat the heat shrink and trim the cables a little, or the string that goes around a little bit, but I wanted to make sure everything was adjusted right. Some parts came in from the tube depot today, which I got a new tube. I didn't put it in yet, but what I wanted to do is, you see over here, I got the 300 ohm resistor in. Remember I said somewhere in the neighborhood of 320, so we'll see. We'll start with 300 and see what that does for us. So I calculated it's about a watt of power that it would dissipate. These are 5-watt resistors, so that should be more than enough. So I'm ready to fire it up, and hopefully we don't get any sparks. I pulled off the positive wires that come from the bridge rectifier, and basically, in essence, put this resistor in between them and the bridge rectifier. And then if that gives us the voltage that we wanted, that we had, it was at 245, 238, somewhere in that area, then we'll find a place to mount that, put that back in. We can put that back together and put that tube in. We'll go from there. So now I'm going to fire it up, and hopefully nothing sparks. It's always a gamble after you've been playing around underneath. Okay, well, it's plugged in and it's firing up. So while that's warming up, let me put it on pause. Alrighty. So let's see. I guess really what we're going to need to look at is the voltmeter over there. And I don't know if it's zoomed in enough. Let's see. So what's that saying? 230 on AM, and this is saying on AM we should be around 245, somewhere in that area. Let's see what we get with FM. FM 224, so they're actually saying 238. So that might be a little too much resistance at 300. So let me drop it down. I got a bunch of them, so we'll see what we can go with. So let me pause it. I'm going to swap that 300 out and maybe go with like a I think I have a 250 or somewhere in that area. I do. I have a 250. So we'll pop that out and throw a 250 in. Okay, now the 250's in. The voltage is coming down. 220, 230, around 230 on FM. Again, they're saying around 238. Let's see what we get for AM. Should be around 245. AM 235, so we can even go lower than this. Let me see how warm it is. Not warm at all. So let me drop down to a 200. Let me put you on pause again. Okay, just threw a 200 ohm resistor in there. And we're on AM, so you know, here's the funny thing. Actually, I'm going to test that with a VTVM. Saying 40 on AM, 245 is about what I should have. That's probably pretty close, but I actually want to put the VTVM, the vacuum tube voltmeter in and check it, because that will make a difference. So let me get that a second to warm up and we'll zoom in on that. Okay, have a vacuum tube voltmeter there, and let's see, we're going to test it. We're on the 500 volt scale, so let me zoom in a little bit so you can see that. Yeah, someday I'll get this right the first time. So try to zoom so you can see which scale to look at. Come on, focus in. You're focusing? A little bit. Almost. Alright. So, here's the 5. See right above my Q-tip there, the 5. So that'd be the 500 volt scale, so just add 2 zeros after whatever you get. 550, 500. So, that being said, you can see here, all zeroed up. You'll see it come to 0. There's 0. And now I'm going to attach it to the voltage. So I'm going to say that's probably around 245 on the nose right there. So that's on just short of 250. You can see the 2.5, 2.5. Remember to move the 0 over twice, so that'd be 250, and it's just a little below that. I'm on the AM CW, or medium wave, so that should be, I've written down here so I don't have to look, 245. That's about perfect. So we're going to want to drop a little bit more to 238 for FM. It looks like 240, but you know, 2 volts. So as you can see, it's a little bit different than, I'm going to zoom out, you see where that's at. And you can see the volt, can you see it? The VOM, the non-vacuum tube meter, that's a little bit lower. Well, back in the days when these things were made, they didn't have those. They had these. So the voltages that they call out, you're probably better off using something like this, other than the fact that you can't get as accurate or granular as you can with the digital ones. But still, they simulate probably whatever the load was that these were designed against. So anyhow, so we're going to stay with the, what do I have, the 200. Let me see if it got warm at all. Yeah, it's getting pretty warm, actually. I'm surprised. I'm going to have to recalculate the current on that to see why that is getting so warm. Okay, well, let me see if I can find a place to mount it on the radio, and we'll go up from there. Alright, now I'm going to get ready and fire it up with the new Itube in. I connected the wire back up that I was testing the other day. So let me get this out of the way. I'm going to have to duck in front of the camera here real quick. Hope the sun didn't reflect off the bald spot. Whoa, look, I saw it move already. Boy, that's really bright. So let's see what happens when we tune in a station. Got it on FM, so I'll need to be an antenna. Well, that's with my hands as an antenna. Let me try AM because that works a little better with me as an antenna. So one thing I'm curious about is if I was to feed in a signal that was kind of like equivalent to an S9, would that show me full deflection? And is there any kind of adjustment on that? Something else I did notice, if you're ever doing one of these, behind that tube in the back, and I'll see if I can give you oversight there. See this back here? That's like a little slider. You loosen the screw up and move it forward and backward, and it'll control how much pressure is on the tube, holding the tube. Because I noticed that the tube just kept falling down in there. There is like a little grommet on the back, or a wiper, or whatever you want to call it, a little piece of material on the back of that holds the tube, but over time it's probably gotten compressed and worn out. So anyhow, that works. So that's another thing marked on. So I just have to decide what I want to do with this resistor. Okay, working on my power reduction problem. So I went with an aluminum bodied power resistor right there, and that's rated at 10 watts, 200 ohms. As you can see here, I have the I don't know if you can actually see that. I'll try to tilt it so you get a better look at it. That's the ammeter's reading 66 milliamps, and the voltmeter behind you is showing the way it's right across the resistor. It's 13.15, around 13.16 volt is the voltage drop. So the voltage drop in the current, if you multiply those, comes out to be a little less than 1 watt of power. That seems to be getting awful hot, that resistor. So my question is, why is it so hot? Do they just get that hot and they can dissipate the power? So let's take one of those resistors and try putting an amp through it at 13 volts and just see what happens when we do it not attached to the radio. Be kind of a good test just to see. And again, it's not mounted to the frame of the chassis, so it's not going to take any of the heat away. But that's what we'll do. We'll give it a shot and see what happens when we put through the power supply. Okay, and so there we have it. I actually used a different resistor, so the current difference is going to be a little bit different, but not much. Just because I've letting this one cool down. Now it's nice and cool. And using that one so I can have a fresh scale. You can see the voltage back there is 13.15, and we're running off a regulated power supply. And right here, through a 200 ohm resistor, it's going to get about 63.6 milliamps. Let's see. It's warm, ever so slightly warm. So the question is, why does it seem to get hotter there? I think maybe if we look at the, actually look at the voltages opposed on the scope as opposed to through the meter, we might find the answer to our problem, or our question rather. So I'll get that set up next, and we'll put it back to the radio. Here we know it's a regulated power supply, what it's going to look like. Very little ripple. This resistor is not even warm yet, so I'll plug this one back into leave everything the same, and then we'll look at it through the scope. So if you look at the O-scope, you'll see there's an awful lot of ripple on there. Let's see, let's put it on the 10 volt scale. 1, 2, 3. There's about 40 volts on there. So let's check it on the voltmeter if we put it onto AC and see what we get. So the AC, the voltmeter showing basically that there's a signal riding on, or our 13 volt signal that we had before is riding on an AC of RMS 16.5, 15, so. Okay, so what I did was, you can see here, we're close to 70 milliamps. I'm probably going to have to recalculate my voltage again, because that's the DC voltage drop. What was 13 point something is now 14 point something, about a volt difference. So I'll have to calculate. It's probably still going to be really close, but just in case. But if you'll take a look, let's look over at the oscilloscope now. Nothing's changed. Same placement on the leads, rather. But look, see all that ripple. There's still a little bit of ripple. You're going to have that, but all that ripple that was bouncing around, that's all gone. So what did I do, you ask? Pretty simple fix, something that I overlooked originally, and I kind of thought I had it, but then when I looked at it, I did not. So let me show you on the 3DBB. All right, is it rolling? Oh, it's rolling. Okay, so I'm going to go over here and point. So originally what I did was I pulled the lead off of here, put my resistor in, and off I went. I forgot that the capacitor was attached to that. So I was in between this and the capacitor, so there was no filtering action happening before that resistor. So basically I was putting the resistor here when I should have been putting it here. So I looked, I said, oh wait a minute, I got the filter lead also. So I put the filter, basically this line's connected, and now I severed the line here, put the resistor in, and as you can see, that takes care of 95.3821% of the ripple. And this resistor is cool as a cucumber. Well, I mean, it's slightly warm, but nothing like hot. So all I'm going to do now is just calculate that that voltage is still going to work for me, except I seem to have all my meters tied up. Okay, welcome back to the Nothing Goes Easy radio station. So I'm probably going to end up finishing this video so it doesn't go on forever and ever. This conglomeration of stuff right here is what I ended up going with in the long run, and it was what I had: a 500 watt resistor, 500 ohm 10 watt resistor, and it bolts to the case. It gets warm. It's been on for about 15-20 minutes, and it's warm. It's not hot. But the nice thing is, since it bolts to the case, it displaces a lot of that heat. And I mean, I guess it's warmer than everything else around the radio, it's hard to say. The voltage here, using that meter back there, you can see it's just a little below 250 on, what would that be, AM, and a little bit below that, probably closer to 240 on FM. That's right about within where it should be. So that's what I'm going to go with. It might be off by 2 volts, actually. Might have cut it down 2 volts more, but that's what I'm going to go with. Nice, nice displacement on the heat. I think that'll get us right where we have to be. The needle looks really well, really good. I mean, so I'm going to do, everything's been like this, and I've been using it. Pretty sure about how the cords have run and that they're long enough. So I'll drop little bits of super glue on that, trim the on the knot just to make sure it doesn't come unknotted, and I'll trim these down. The next thing I was working on is the actual bulb that goes in there. Well, again, because it's not an American-made radio, it's a little bit tough finding the exact bulb that goes in there. They had a 1447 in there. It's an 18-volt bulb. According to the schematic, they should take a 7 volt at 0.3 amp. So what's that? Put it about 2.1 watt bulb. That's a 50, the number 50 bulb, but it doesn't seem to screw in correctly. So I have to look and see, is there a difference between the thread base? I thought all these miniature candelabras were kind of the same, but on the 1447 and the 50. And then maybe get a light bulb that looks a little bit better. I think the bulb that belonged in there was longer. You know, they have the longer bulb. That's just a round bulb. I'll turn it off so you can actually see it. I don't know if you can see it or not now, but anyhow, so that's what I'll do. I'll put that resistor in and clean up the glass plate a little bit, clean up the radio some more so I can put that back on. Trim these done, the front will be ready to go. And then I think the next one to do is clean the actual wooden case and do an alignment on it, probably all. And then I think we can stick it inside there and see how everything works with that. But yeah, I figured I might as well sum this up because I thought maybe I'd be ready to put it back together, but it's just one thing after another, you know, finding the right resistor, finding the right bulb. So, like I said, I'm not in any hurry. We'll mow through it as we get through it. I guess you saw that the tube works well, and that's where we're at. So, thanks for watching and keep tuned. We'll get you another one, hopefully when it's a little bit closer to done, or if I find anything more interesting. There's really no need to watch me put some screws back in or clean some parts. So, again, like I said, we'll be back. Thanks for watching, and stay tuned for another exciting episode of the Grundig, whatever you want to call it. It's the Grundig Radio.